Today I'm going to teach you about Riemann sums, which is a very important concept to grasp when you're learning about integrals. So what is an integral? Well, an integral is an area under a curve. Any curve works, like a polynomial curve or a logarithmic curve, anything like that. And so when we're finding an integral, we usually are given intervals, so we can, to make us find, like for example, in this graph below, we to find the area S, we need to know that the intervals that this area is between is A to B, like that. And when we're doing integrals, it's very nice to use approximation to help us find the area. And so when we're doing approximation, we would use rectangles to find rectangles with usually uniform width, meaning like the same width for each rectangle, to approximate this area, right? And so in this case, we can see that after using 4 rectangles, there is still the space that we're missing under this curve over here. Which tells us that it's approximation. It's not completely accurate. And so in this case, we have underestimated the actual area. But if we make these rectangles widths even like smaller, then we see that we're getting closer to the actual area under the curve. Sorry. And in this case, when we make them even smaller, they get even closer. And so that brings us to right Riemann sums and left Riemann sums. So on the AP test, you will need to know how to find these different kinds of sums. So for left sum, when we are using these rectangles to approximate, we use the height to calculate the rectangle from the left side over here. And for the right Riemann sum, we're just using the right side over here. And so in this case, we can see that the right Riemann sum overshoots the actual area under the curve, while the left Riemann sum undershoots it. So it's an underestimate. And so now talking about overestimations and underestimations, we need to know when a left sum would be an underestimation and when a right sum will be an overestimation. So this is the rule for determining this. So when the direction is increasing, like for example, in this graph, the curve starts by increasing, and this entire Riemann sum is a left Riemann sum. So we can see that when the curve is increasing, the left Riemann sum gives us an underestimation. But when the curve decreases, it becomes an overestimation. So an easy way to remember this is just knowing that increasing for a left Riemann sum is underestimation, and decreasing is overestimation. And for the right Riemann sum, it's the opposite. So calculating Riemann sums. So here's an example to make visualizing things easier. So this red curve over here is y equals x squared. And so to find the area from x equals 1 to x equals 4, which are these 2 green lines over here, with a left Riemann sum, and for each rectangle to have a width of 1, what we have to do is, let me just annotate the screen. So we would need to find the height, because we know the widths of each of these rectangles is 1. And so the height, we have to plug in this value, as this is a left Riemann sum. We would plug in this, which is 1 over here. So we would do y equals 1 squared, which is 1. So 1 times 1 for the height times the width would equals 1. And then we would move to here, this point over here, to find this height. This is 2. We would do y equals 2 squared, which is 4, the width times the height again. And for this last one over here, this is 3 squared, 9 times 1. And all we have to do is add these rectangles together to get our approximation. And our approximation would be this. And so our final answer would be 14.